Yeah, we'll try to keep it somewhat informal, honestly, because I think as Sebastian highlighted, there are a lot of folks that are pretty sophisticated around the use of our products here, and so it's really just a forum for information sharing. As I'd said, one of our roles as a vendor that is super fascinating to me, and probably the most interesting part to me, is to be able to play back what we've learned by watching everybody adopt cloud and try to simplify some of the patterns for other people to consume. Just as we have about, we have thousands of customers. I think, just put a number on it, I think we're about 200 of the Fortune 500 as commercial customers. So this is a pretty well-trodden path. Obviously, we're a public company for a reason because we know what our products do. They're in the runtime paths of stock exchange and video games. I was just saying, actually, the very first event we did like this, someone from EA Sports or Electronic Arts approached me and said, I just want you to know that every instance of FIFA soccer spawned on Consul. I was like, oh, I didn't know. That's pretty cool. Kind of freaked me out to know that because they were not a customer at the time, but they'd built mission-critical infrastructure on our runtime products. As I highlighted earlier this morning, this maturity model of cloud, I think, is the magic formula that we've observed around people that are doing this. This notion that at some point you have to bring the chaos under control, and you can't have 10 ways of provisioning. You can't have 10 ways of doing identity-based security. You need actually an organizational structure that supports bringing it under control. And it's a very well-understood concept in the world of platform engineering for application development, but the same things happen in cloud. So this notion and this picture, I think, is important because there are 4 layers to infrastructure software. There's the runtime layer. You have some Kubernetes apps, some Java apps, some Spring apps. It's a whole host of different kinds of apps. But you need consistency with respect to how you do infrastructure, security, and networking underneath that. And so our product portfolio represents that org structure evolution. Oh, there you go. Yeah, so this notion of maturity, what we see our customers doing is actually progressing layer by layer. That vision is a really, really big thing to consume, and for most companies, it takes years to do that. But the good news is there's a very simple way to get started, which is, hey, let me think about the evolution layer by layer. Most people start with the provisioning problem because that's the control point to all things cloud. Then you run into the security problem, then you run into the networking problem, and that is just sort of the evolution everybody goes on. So this maturity construct is one that I just wanted to play back to you. So if we think about what happens at the provisioning layer, there's a very repeatable model here. And people think about it in terms of use cases. In fact, I'll dial it back. We were having dinner with somebody last night, and someone who runs the cloud program for a large company, and they said, your stuff is so nerdy, it's hard to talk about. and that is true. I actually find myself getting asked at dinner parties, so what does HashiCorp do? And I'm like, well, how much time do you have? Where do you want to start? And I think what we've learned is actually we need to pull it back and just distill the use cases that people go through, and then it all comes into focus. So if we go, okay, got it, let's talk about standardized provisioning. There's a starting point organizationally, which brings that together in the form of Terraform Cloud, typically, where people run that as a shared service. And the very, very first thing they do is they then apply that to their cloud estate. They go, got it. We bring in Terraform as a way to constrain provisioning of cloud. Cloud's really expensive, so therefore let's bring it under control. And so great, I stand up Terraform as a shared service for everybody going cloud. Cool. That is a huge, huge value proposition for the organization. But then over time, what happened is we started to see that people were building Terraform providers for networking gear. And we're like, that actually didn't enter my mind all those years ago. But we actually let Cisco be a small investor in HashiCorp as we started to see this as a private company. And so whether you use Cisco ACI or Palo Alto Networks or F5 or your security appliances themselves, most of those people in the modern world are using infrastructure as code to configure them. Right? So why use a ticketing mechanism that use some sort of configuration management technology to update the routing rules in your networking gear when you can just Terraform apply is, Terraform destroy isn't. In fact, there was a really big outage at Capital One last year. When I met with them, they were like, hey, just want you to know, the reason we were able to roll that back so quickly is because we used Terraform as the basis for all of our networking configuration. We rolled it back to the previous version, and it instantly all worked again. So your next use case along, as people mature, tends to be for networking. Then they go, hold on a second, I can use it for my private data center as well. And then the last one, and this one's been fascinating, I actually credit someone in the UK for showing this to me in the first place. There are 3,000 Terraform providers out there. And I would say maybe 1,000 of them relate to SaaS applications. So there's a Terraform provider for GitHub, for GitLab, for Salesforce, for Workday, all these SaaS applications. And it turns out people have started using that same Terraform infrastructure to automate the onboarding of users into SaaS applications. So now what I can do when a new developer onboards, rather than having to wait 2 months for them to be set up in all the systems, there's just 3 Terraform templates. Terraform apply, and they're done. Right? And now I have MFA enabled on those SaaS applications. I have the directory structure that is the standard for my organization. They're good to go immediately on day 2. So this notion of using Terraform for its SaaS applications is super, super popular. And I would just suggest the evolution of maturity goes left to right here. So I'm not sure where you all are in your particular path, but this is a prescription. This isn't a marketing contract. It's literally just playing back what we see. Having to explain the value proposition to someone perhaps that's not as deep in the weeds as we are is where it often gets difficult. So great, why should we invest in Terraform to standardize the provisioning process for all those things? Okay, well, the value proposition for any piece of technology, like when we distill it down, it's these 3 categories. It's reduce cost, reduce risk, and accelerate time for new things. Any piece of technology that we adopt is for doing that. So let me just spend a second helping build that translation into really simple English language on the value proposition for adopting Terraform as a shared service, whether it's for SaaS or for networking or private cloud. Point number 1, eliminate over-provisioning. I confessed recently that we spent $14 million on Amazon last year as a company. And when I looked at that, I was like, well, that makes sense to me. We run HCP, managed services, on Amazon. Surely that's what it is. Turns out that was only $8 million. I was like, what about the other $6 million? And people were like, I don't know. Turns out it's because I have SEs, I have support people, I have engineering people, all of whom are just provisioning things to Amazon. And so we had to bring it under control. That's $6 million of waste that you all have in your organizations too. Because there's no doubt that at least 10% of the cloud compute that you get billed for every month is unnecessary. It's in the form of either over-provisioning capacity. Hey, I'm provisioning an application. It really needs a small instance, but I put it on a large instance because I could. And now you're being billed twice as much as you should because some application developer said, well, it doesn't really matter what it goes on. It'll just go, right? So by centralizing this as a shared service, by making available predetermined templates, there's a small template, a medium template, and a large template, and you can now enforce policy with respect to which templates gets consumed. It is like dead simple money savings opportunity. The second one is what we were experiencing, which is this orphaned infrastructure. Our devs would spin stuff up, and they'd be sitting out there for 6 weeks before I realized it was there, and it was just turning the meter. There's a gaming company that I talked to that they confessed that they had one analytic instance. It was costing them $10,000 a day, and it took them 6 months to figure it out. Like, that's how big these companies are. You all are spending hundreds of, in some instances, literally hundreds of millions of dollars a year on your cloud estate. You're not even aware of how this is happening. So being able to put a control point over the provisioning process is the only way to save the cost that tends to happen. One of my favorite use cases is actually one of the biggest retailers in the world. They run a hybrid estate, and they confess they use Terraform to control where things are being provisioned because their second biggest cost of their cloud estate is networking ingress-egress costs. So if they have an application that's populating the data warehouse, well, their data warehouse is Snowflake. It's running in Azure East. They have a bias to deploy things to Azure East that are populating the data warehouse. Like, that's how you save enormous amounts of money on your cloud estate. So the cost savings thing is I almost go like I don't even know how to size the cost savings aspect because it's so obvious to all of us that if you can constrain the provisioning process, apply policy to that provisioning process, that is an enormous opportunity for savings. So if you're spending $30 million on your cloud estate, I would argue at least $3 million of that is wasted. For a very small investment, you can bring that to zero like we did. But there's also a risk value proposition, right? By virtue of making available central shared service of templates that get provisioned, you can prevent things getting deployed that don't have your security elements, that don't have your security agents, that have things like the S3 buckets set to open by default, which I'm sure happens in your company. You have the ability to constrain what's being pushed out there. So actually, I would say 30 or 40% of the time, we're brought in for Terraform Cloud by security teams because the only way to prevent risk from happening is stop things from being provisioned that you don't want. Yes, you probably buy Palo Alto, Prisma, or whatever to monitor what's happening in that environment, but fundamentally, the best constraint is not letting things be provisioned that are not approved. And then lastly, the whole notion of infrastructure code is about getting away from this ticketing process. Like you think about how you provision a virtual machine today. I open a ticket, that pages somebody to provision a VM. Next ticket along is now configure the networking associated with that. Next ticket along is get the sign-off from security and the firewall around it. Okay, that just took 3 weeks, right? I can assure you, your competitors do not do that. I actually worked at GitHub, just to use that as an example. GitHub, pretty popular SaaS application. We deployed GitHub multiple times per day. At any point in time, there's probably 100 million users on that application. The only way you can do that is because they use Terraform Cloud as the basis of constraining what can be deployed, so every deployment is identical. It's identical. It's just a small change to the application. That's what your competitors are doing. Just know that, and this is how they're doing it. So anyways, I just use that as an example. I think this framework's instructive as we try to justify internally to our peers, why we have to go on this maturation journey. There's countless examples. There's lines. The cost is it's almost comedy to me because the scale of spend of cloud is so big that a 2% waste is a massive number for everybody, and this stuff gets away on us. So obviously, global life sciences company. A commercial real estate team. We actually have a team called our value team or something that does like custom engagements for folks when they're trying to justify it. So that's where these numbers come from, right? This is real dollars associated with risk savings from service stability, which means your services, your applications are getting deployed on a far regular basis, and those are revenue generating applications that if blocked by your security team, cost you huge amounts of money. So I won't belabor the point. I think the construct makes sense. So people start with the provisioning problem generally, and then they realize, what? I now have a security issue. I'm not provisioning things outside of my environment. In my private data center, it's all pretty safe inside a network protected, perimeter protected with a firewall. Well, in the cloud world, it's all outside the firewall, so there's just a fundamentally different construct. So this notion of authenticating the identity of every machine before you talk to every other machine is just the standard way we do security in cloud. That's how Zoom works. It's Vault. That's how they do it. That's how WebEx works. It's Vault, right? Because all that stuff's running outside of the data center. If you're running a connected car program, that's Vault. If you're Uber, that's Vault, right? That's how this all works. Right, so this notion of having to put this authentication mechanism in place before every machine connection happens is actually pretty well understood, but it's hard to explain to non-technical people. So there's a similar progression that we've observed, and again, I'm just playing back what we see to the extent that it's helpful. People go left to right as they think about that maturity journey, and for some people, this takes them 3 years to get from left to right across their estate. Step one, people bring in Vault for secrets management. Before this machine talks to this machine, issue a dynamic credential, right? That is probably the starting point for every Vault instance. Sometimes people actually just use Vault to do credential rotation. So we have customers that literally have put Vault in front of thousands of databases just so they can rotate the credentials on those databases every 90 days because they're regulated entities. Because previously what they had to do is have someone in India log into all those machines and rotate the credentials every 90 days. And that is a crazy thing to do, and you can make your own cost estimation on that one. That should be done in a script. And people are laughing because a lot of people are doing that. That's just how it works. So using Vault for secrets management is where people start. They then go, you know what? I have certificates as the basis of everything around my estate. How do I do the certificate rotation process? So before every machine talks to every other machine, I want to validate a certificate, certainly, or validate its identity via certificate. But how do I rotate the credentials, those certificates themselves? You will have, tens of thousands and if not hundreds of thousands of certs around your estate. Just to give a sense of the scale, one of our gaming customers, gaming company customers, it's not EA, runs 100,000 servers. 100,000 servers, all authenticated using certificates. Their certificate lifecycle across that is just a mammoth challenge. They use Vault to rotate the certs across that estate in an automated fashion. So the second biggest use case for us is actually the certificate management use case. As people mature, they go, hey, I have all my machines connected via Vault. Now let's manage the certs on all those machines via Vault. We actually see this for what it's worth in a lot of endpoint devices. Think about the thermostats in the building. Well, how do you think they authenticate their identity? right? We know how they do that because they use Vault generally. The third use case people get to is actually for managing the key lifecycle. This is an HSM-related problem for a lot of people. How do I seal and unseal? And so Vault can also act as a software HSM. If you use Vault, you can use that already. Like using it for the key lifecycle is a huge part of it. It actually both integrates with HSMs, but also can act as an HSM, a software-based HSM with FIPS 140-2 certification, because as you can imagine, a lot of folks in the government world use Vault for this purpose, and they forced us to do that over the last few years. The fourth use case, and this is a kind of a more sophisticated one, is the notion of encryption. Really cool example of this actually is I've seen a bunch of people using Vault to encrypt the data that is flowing into Snowflake, or encrypt the data as it comes in that's flowing into their Hadoop estate. So this notion of once I have my machines connected, this is just a setting essentially. Once this app, is connected to this app, I can just enable encryption between those two things without modifying the application itself. So I would say, this is, in fact, there's a public case study on this, the Chicago Mercantile Exchange, because they've talked publicly about it. This is what they use Vault for. It encrypts every trade that goes to the Chicago Mercantile Exchange. But it's the same, they happened to get here eventually, but they went through this life cycle to begin with. So I just going to present this as a framework to think about the evolution of maturity. Again, I'm not sure where you all are in your use of Vault. You can see, one of the key things that we announced today, it was a little hard to consume, was this notion of even, in the world of just for secrets management, this notion of secret syncing. So what that demo showed is someone using AWS Secrets Manager, because they have secrets in AWS, you have secrets in Kubernetes, you have secrets on Azure Key Vault, you have secrets in all these places, but I need to manage the life cycle of those secrets from a central place. So that has been a big focus of ours with that secret syncing capability, which means you can now put secrets in different places, but have them centrally managed, the life cycle of them managed by Vault. This notion of a centralized identity broker for these use cases is just a core capability of literally every company in the Fortune 500. You can use that exact same framework to articulate the value proposition, because I know it's a little trickier with Vault, but there's a cost, risk, and speed value proposition around the use of these use cases for Vault. So I'll give you a couple of examples. The first one, I don't like to take a poke at Palo Alto Networks, but if you're using the traditional model of like perimeter-based firewalls for all the new things you're deploying to cloud, like you're spending a lot of you're paying Palo Alto a lot of money for a lot of licenses that you probably don't need, because those should be authenticating themselves through the assumed zero trust approach of using Vault to authenticate every machine-to-machine connection. You're way overspending on traditional software to solve a problem which actually doesn't exist in the cloud world. I can assure you the gaming companies and the cloud-native companies you all compete with are not deploying firewalls to their public environment. They're using the identity-based control and just assuming that that is safe. So certainly a cost savings here. The second one is around the secret rotation thing that I described. And the third, like, very clear cost value proposition is around tools consolidation. So if I go back to this view, one of the weird things of cloud is that these are all distinct markets in the private data center. You probably have a vendor in each one of those things. Well, it turns out in the cloud model, these markets get reconstituted and recreated in a slightly different way on cloud. And actually, there's an opportunity for tool consolidation, because Vault does all those things. Certainly it's not going to do them as well as some of the things in the more sophisticated arenas, but I would say for a huge percentage of your use cases, there's a massive cost-saving opportunity through tool consolidation. On the risk one's obvious, right? Like, there's a stat that we've shared in the past. I think something like 95% of the companies that have had public data breaches are now Vault customers. Because the only way to prevent those data breaches where people get into your database is by authenticating the identity of everything before it tries to get into the database. So you have to literally insert something in the runtime path. And so that is what Vault does. Just to give you a sense of the scale of it, we have customers that do that 1 billion times a day, right? That scenario. Think about the scale of that. So this is a very easy sale to an internal constituent. So like, you either are or you are not secure. And I think we all understand that one well. The other one is around eliminating secret sprawl. If you don't have a centralized way to force your teams in the development arena to put their credentials, they will end up everywhere, right? So if you can enforce through a centralized platform engineering organization, a centralized approach to credential management, that eliminates secret sprawl. One of the big investment banks in the US actually told me last week I was speaking to their head of identity. He said they have a board-level mandate this year to get 10% of their estate, 10% of all the applications in this company inside Vault by the end of the year, because they're realizing they have secrets everywhere. Like, so this is a Fortune 50 company that is saying, you know what, I have a secret sprawl problem, and so do all of you, and we need to enforce a centralized way to do that. And then the unauthorized user access is really a commentary on the boundary value proposition, which we talked about today. I would just say that boundary problem is one that I've heard from literally 90% of organizations I've spoken to in the last year. They go, yeah, that's a well-solved problem in the private data center. I use CyberArk for that. In the cloud world, it's just architecturally a different problem. Could you help me with that? And that's the boundary bit. The speed thing, again, it's actually pretty self-explanatory. Like, think about the security model today where it's more of a break on your organization where they go, hold on a second, open a ticket, I will create a secure network perimeter around this, and then I will give you the thumbs up when this application can see traffic. Again, that is not how your cloud-native competitors are doing it. They are shifting that process right, which is deploy an application, it authenticates to Vault. As long as Vault says, yeah, this role is allowed to talk to this role, it talks to it immediately, right? So the speed for applications actually seeing traffic is night and day. Yeah, you're deploying 10 times a day, not once every 3 days waiting for security teams. And the biggest value prop for the security organization is really like it's a mind shift to say like, yeah, I want to shift from being a constraint to being an enabler. And so philosophically, if I have this machine-to-machine auth mechanism in place, then I'll let applications go as long as they meet the policy that I have in place. Like, sure, I'll let them go. And that is the dream scenario you're trying to get to. Again, lots of really easy examples, and our teams, I'm sure, would be happy to talk about the customer examples of how this works. But the the notion of speed to market is probably my favorite one. A global analytics software company, like they gave this information back to us, is to say like their regulatory compliance regimes are massively accelerated by virtue of this policy-based model for machine-to-machine connectivity. The third layer that people get to, like you think about how it goes, you kind of go like, got it, I've solved the provisioning problem, now I've got my hands around the security problem. We all know that the long pole for applications seeing traffic is the networking team, and oftentimes they're the last ones to go. So this notion of like waiting for the networking team to update the routing rules for what just got deployed so that those apps can see traffic just is the reality of the constraint. There's a very, very similar process then that people go through using Consul. Consul is actually our second most widely used product, just for what it's worth. It's a super nerdy tech, but it's probably the most important when you're running distributed systems. The use case evolution is actually also very, very, very well understood. People start using Consul for this notion of service discovery. Hey, I have applications all over the place. I need to update the DNS. I need to be able to speak DNS when things get deployed so that I know application A talks to application B. Next time it gets deployed, it's on a different IP address. Next time, it's on a different IP address. So it's this shift to using service name as the basis of networking as opposed to physical IP address. And service discovery is the core construct. Again, a relatively mature concept. But that is where everybody starts. That's where everybody uses Consul for today, right? If you are trying to have app A talk to app B in the cloud model, you have to use this model because otherwise you're waiting for someone to update the networking rules, and that doesn't work. So that's where people start. The next use case along, and this actually, I remember the day, it was in 2017, we were meeting with one of the biggest healthcare company in the world, and they said to us, you know what, we use Consul extensively for service discovery. It's the basis of how we do routing for a lot of our applications. Is there any way you could encrypt the connections between everything when it speaks? Because that would save me a lot of trouble of having to build complicated network topologies and sub-segment networks and adopt a really complicated network segmentation policy that makes it really, really difficult at scale to manage. And so we were like, actually, I remember Armon whiteboarded it for them, and this notion of like, hey, what if I just enabled MTLS between those things as a setting when they talk? Would that solve your problem? And they were like, yes, and that became the service mesh market. That was literally the moment it started. And then actually Google ended up literally copying in many, many ways with what with the Istio technology that they put into Kubernetes, but it's the same notion. As Istio is to Kubernetes, Consul service mesh use case is for everything else in the world. So if you need a Kubernetes element to talk to a database, well, that's the problem, right? So this next use case along is literally just a setting, saying I'm using Consul for the service discovery and networking. Now I want to be able I want to enable encryption between those elements when they speak. And that's sort of the next step along. As people get really, really mature, they actually start linking old world and new world, and they say, hey, I use Terraform to configure the networking estate, my Cisco routers, but now I'm deploying things on cloud, so maybe I have routers here that are configuring the networking around my database estate, but now I'm deploying things to cloud because my mobile banking application runs up here, and this is using Consul, and every time I deploy it, it's on a different IP address. So what we did with the work, with the help of a lot of the networking vendors, is enable the linking between the two. So actually, if you use Terraform to deploy things, we'll actually queue up remediation to the Terraform template for your on-prem networking configuration to reflect what just got deployed out here. And that's the automation process. What do we call it? It's called network infrastructure automation, if you look for that on our website. And we do that with Cisco and F5 and all the Palo and all the networking gear you'll find. But again, there's a progression of use cases. The same value proposition when you're trying to make the case internally holds. Why would you do it this way? To reduce cost, to reduce risk, and accelerate time for new things. Really good example, like how many load balancers have you deployed in your cloud estate to create static IP addresses so things can be found? Like lots, I would bet, right? You've made F5 a lot of money. Ultimately, they bought Nginx, I think, because people were spending way too much money doing that, so there's some open source alternatives, but there's a management overhead associated with that. The service networking model doesn't require that. You're not deploying thousands of load balancers, or certainly hundreds of load balancers to do that. The other cost savings aspect, like one of the big e-commerce applications in Singapore, they actually use Consul as the basis for all this network routing. And again, for them, a lot of their cloud costs are networking costs. It's networking egress costs. And so they actually use Consul to intelligently route between zones so there aren't the unnecessary bounces to load balancers, such they save an enormous amount of money on networking costs on their cloud estate. So what you've essentially done is you put like an abstraction layer on top of the networking layer, so you can actually now route traffic around in a way that doesn't force you to pay the tax of routing within the Amazon environment. On the risk side, it's pretty self-explanatory. The way people configure the networking rules in service networking technologies like Consul is they use Terraform. So there's a Terraform template that says, here's the routing rules for this Consul instance. When I duplicate this to another environment, I just deploy that same template, deploy the same template, deploy the same template. For obvious reasons, that massively reduces the risks. And then the last one, obviously, like this is how you get to that continuous deployment model. Like if you're using the service networking construct, every time an application gets deployed, it sees traffic straight away. So that GitHub example I used actually is probably a good one because, like I said, they deploy 10 times a day. They use Terraform for the provisioning process. They use Vault to authenticate the identity of everything's out there, and they use Consul for the networking of it all. Why? Because it turns out those three elements are the pieces that are required for an application to see traffic immediately when it gets deployed, and they get out of the way of the application teams to do so. Again, the litany of customer examples is almost too long to share, but I think you kind of get the point. I guess my final point is like this is the sorry, I jumped me through. Let me go back one. There you go. Hold on a second. This picture is the one. Like this is just the truth of how people do it. Is maybe my final point. There are a myriad of application types: Java apps, serverless apps, Kubernetes apps, Edge apps. You will have all of them. The thing that's different is those applications are not running outside of your data center. So the thing that is different is you have to rethink how you do ops security and networking to reflect that new world. And that's ultimately what people are doing with the cloud model. So that's the picture that everyone gets to. They get there basically layer by layer, and we're happy to give more details on what we see and the pitfalls of it. But like I said, when we talk about 200 of the Fortune 500, this is the picture that they put in place. And obviously, the cost, risk, speed value proposition is how that gets justified internally. I am certain that if you put Terraform Cloud in front of the provisioning process, you will save a material percentage on your cloud estate spend. So anyways, I'll be here all day. I just wanted to have the opportunity to walk through that talk track. Obviously, you can see I'm pretty passionate about it because the favorite part of what I get to do is play back what I hear, and I think it's just a really neat part of the vendor relationship. So I'll get out of the way, and Sebastian, I think you're up next with the next speaker.